Welcome to Point channel. So today I'm going to discuss about N+1 problem in Spring Data JPA. So in this video I'm going to discuss what exactly N+1 problem and how it impacts the performance. And is eager fetching really resolves the N+1 problem? So and what would be the fix for this N+1 problem? So basically there are two solutions: join, fetch, and entity graph. So I'm going to discuss about these two methodologies. Okay, yeah, without wasting time, let's jump into the coding part. Yeah, so before moving into the code, okay, let me show you one image. Okay, yeah, so in order to demonstrate this particular demo, I have taken this particular example. So here I have considered four entities. So left side one here, if you see department. So I have three departments: HR, sales, and IT. So this department has one to many association with employees. So right, one department can have many employees, and many employees are associated to one department, right? So this is basically one to many association between department and employee. Now coming to employee and project, so this is many to many association, right? Many employees can associate to one project, and one project can have many employees or something like that, right? So and here if you see, each project can have one project manager, right? So here if you see, this project is having project manager with the name Ashok or something like that. So this is the example which I have opted to demonstrate this particular demo. Now let's go through the code. Okay, so just some time before I have created one demo project. Here if you see, this is the N+1 problem. Okay, so here we have an entity package. So let me show you one by one. See, the first one is department entity. Okay, see, this is department entity. Hardly we have three fields: ID, name. Here I have at the rate one to many association with employees, right? So this here I have this mapped by attribute. Obviously this acts as a non-owning side, right? So now if you see the employees, okay, so here employees, here you can see employee ID, employee name, salary, and department at the rate many to one, right? Obviously many to one. And here this employee is having at the rate many to many association with a set of projects, right? As I explained just some time before. Okay, now if you see this project, okay, so this project here, yeah, we have project ID, project name, and a one-to-one association with manager. Each project has one manager, something like that, right? So here, if you see, and if you see manager, manager has only two fields: ID and name. That's it, right? So now, if you see, we have this repositories. This is a department repository. I will go through these methods. After some time. Okay, so here if you see, we have employee repository and we have project repository. That's it. Okay, so just to overcome the lazy initialization exception, I have written one class with the name lazy testing. That's it. Okay, and here if you see, this is just a main class in which we have this main method. That's it, nothing fancy. Okay, here in the resources folder we have application.properties. I'm just connecting with MySQL database, so obviously I maintained a MySQL data source related properties, right? So here I have one test case just to demonstrate all the relevant test scenarios of this N+1 problem. Yeah, so this is a high level code walkthrough of my demo. Okay, so now so let's discuss one by one scenario. Okay, so before going to this first test scenario, so I'm going to insert the records of what you say, um, of all these four entities into the MySQL database. So obviously department table, employee table, project table, and manager table. And since we have many to many association between employee and project, okay, employee is acting as a owning side. So obviously employee underscore projects, one more join table will be created, as I explained in my previous video, right? In many to many association, right? So Yeah, so let me show you my SQL workbench. I'm just refreshing. Yeah, see, I just refreshed, nothing, there are no tables. Okay, now let's execute the first test scenario. Okay, here if you see insert all records, right? So, so let me execute this particular test case. Okay, anyhow, it will take some time. So meanwhile, I will explain you what I'm inserting over here. Okay, so here if you see, initially I have created three manager records. Okay, here if you see, I have created three project records. So just visualize this diagram. Okay, then you will feel comfortable. So three managers and three projects, right? So then here if you see, uh, then three departments. Okay, then three departments, and here if you see, seven employees. Here if you see, seven employees. Why seven employees? Here you can see, first department is having two employees, and second department two employees, and third department, IT department, has three employees. So 2 plus 2 plus 3, obviously seven employees, right? So here if you see, seven employees. So here each employee is having many to one association with the department, right? So that's why I'm passing here department. Here note this point. Okay, here I'm passing department. So now, yeah, so department is acting as a non-owning side. So I mean, finally I'm going to save the department record. So that's why here if you see, I'm just tying up all the employees to that respective department, hr.getEmployees.add of Ajay, Ravi, or something like this, right? So this is that piece of code. Now if you see here, what I am doing here, ajay.getProjects.add of HR project. So that means here if you see, I'm just tying each project to this particular employee, right? So here if you see, we have seven employees. For all the seven employees, I'm just tying their respective project to this particular employee by this way, ajay.getProjects.add of here HR project, here also HR project, or something like this, right? So um, so here, yeah, so here if you see, we are tying manager to here in the, I mean, to each project. Here if you see Krishna, Ashok, okay, I'm passing manager names to the constructor of this project. Okay, now it's clear, right? So finally, I'm just saving the department, department records. Now if you see, we have maintained cascading functionality. Here if you see, okay, once again I'm showing here, if you see cascade is equal to cascade depth at persist. Okay, now if you see the employee, okay, here also we have cascade is equal to cascade depth at persist. Now if you see the project, okay, here also we have cascade is equal to cascade depth at persist, right? So obviously if you save the department record, internally it will take care of all its child records. So in a single shot it will create records in all the respective tables. Now if you see, test case is passed, right? So now let's examine the database. Okay, I'm just refreshing. Okay, yeah, as I said, if you see, we have five tables: department, employee, and employee underscore project. Okay, and manager and project, right? So here, if you see one by one, okay, I'm just refreshing. Okay, department, three departments. Just I mean, HR, sales, IT department, right? Obviously, we will be having seven employees. Yeah, here if you see seven employees, here you can see department underscore ID. This is a foreign key column. If you see, first department is having two columns, and second department is having two columns, and third department is having three columns. Something like that. I mean, three employees. Sorry. So here, if you see employee underscore projects, as soon as I refresh, now it is showing the relation between employee and project, right? So first two employees are associated to single project. Okay, second two employees are associated to second project, and after that, last three employees are associated to third project. You see here, 5, 6, 7 are associated to third project, right? So here I'm just refreshing manager. Yeah, so three projects, sorry, three managers: Krishna, Ashok, and Rajendra. So these are, I mean, these are the project manager names. Okay, here if you see, I'm just refreshing project. Here if you see HR project, sales project, and IT project. So yeah, we are good. We just saved, I mean, the records in all the tables. Okay, so now it's time to verify this N+1 problem. Okay, so here I'm just closing all the tabs. Okay, I'm just opening the test case here. Okay, so here if you see, the first test scenario, fetch department records. Okay, so here if you see, what I'm doing, I want to show you the records of only this department and employees. Okay, if I fetch department, okay, I'm trying to print their employee names. That's it. Okay, so then internally how many queries it is going to fire, that I want to show you. Okay, so here if you see what I'm doing, I'm just fetching all the records of department just with the help of find all. Okay, so once I got the departments here, if you see, I'm just using some streaming operations. So stream dot collect of, so what I'm doing, I'm just converting to map. So I mean, so my intention is to have a map with the key as a department name and the value as their employees list. Okay, so here if you see, after that I'm just iterating. Okay, so here key I'm printing as it is department name, and here if you see, the value is nothing but a list of employees. Okay, so here what I'm doing, I mean, I'm interested only their names. So that's why again I'm converting this map to employee dot get name or something like that method reference. Then I'm just printing. So here overall what I'm doing, I mean, it will print department name and their respective employee names for all the three departments, right? So now, okay, let's run this particular code. I mean, in debug mode. Yeah, so in just debug mode I'm just running. So here if you see department, okay, department, we are having a lazy association. So here if you see, yeah, this is our department. So here if you see, we are having lazy association. So as I said in my previous videos, at the rate one to many, at the rate many to many are having by default lazy association. Only at the rate one to one, at the rate many to one are having by default eager association, right? So obviously now let me move it to a bit down. Okay, so here this one. Okay, yeah. So let me show you the console. See, console is empty. So now we are having lazy association between the department and employee. So now I'm just fetching only department records. I'm just moving the flow to the next line. Okay. So here if you see, uh, so we are only one query is fired to fetch all list of departments. That's it. Only one single query is fetched. Why? Because it's a lazy association, right? So now if you see, as soon as I resume the flow, okay, so here I'm just resuming the flow. Okay, so now if you see, now here, mm, yeah, so here if you see this is the first query. Yeah, so this is the first query to fetch all list of departments, first query. Now so now just visualize this particular diagram. Okay, so here left side, see, just to fetch all list of departments, one single query, and for each department's child records, uh, one query will be fired. So that means to fetch list of employees for the HR department, one query. Similarly, to fetch list of employees for sales department, one query. To fetch list of employees for IT department, one single query, right? So that means 1 plus 1 plus 1, 3, and here this is the one query. I mean, to fetch list of departments. So total 1 plus 3, total 4 queries will be fired. Okay, so here I just prepared one more diagram. Here if you see, I mean, to fetch all list of departments, one, so first query number 1 is fired. Now for HR department related child records, query number 2. Sales department related child records, query number 3. IT department related child records, query number 4. So that means what happened, whenever I fetch list of department records, 1 plus 3, so that is total 4 queries are firing. So here n plus 1, so 1 plus n in the sense, n represents the number of parent records. So here parent records in the sense department records. Here we are having 3 department records. For each department's child records, it is firing single query, right? So total 3 departments, 3 queries it has fired. So 3 plus 1. So this is the context of n plus 1. Okay, now practically I will show you here. Okay, so this is the query. Okay, so this is the query number 2. Okay, query number 2, here if you see, it has printed sales department and their employee names, Manisha and Nikita. Okay, now, okay, here if you see query number 3, query number 3, so this is for HR department. Here if you see, it has printed HR department, Ajay and Ravi. Okay, and this is the query number 4. Okay, this is the query number 4, and this is for IT department. Okay, obviously Anil, Jayant and Mohan, these are the employees. So now it's clear, right? So the first query is fired to fetch the list of departments. So this is the first query, or to fetch the list of parent records. and after that three queries are fired. Okay, three queries are fired to fetch each department's child records. So this is the N+1 problem. Okay, so so unnecessarily it is firing queries where, whenever it is trying to print the each department's child records data. Okay, so now you may have one doubt. Okay, what happens in case if we have a eager fetching between department and employee? Okay, so now let's do some experiment. Okay, here we have at the rate one too many. Okay, till now we have seen lazy fetching. Okay, so now let me here. See, I just enabled eager fetching, right? So now, since we have eager fetching, obviously, it may resolve N+1 problem. So such kind of assumption you guys may have. So let's see practically what happens if I have eager fetching, right? So now I'm just running the same test case once again. Okay, so yeah, so I'm just running in the same debug mode. Yeah, it will take a while. Just bear with me. So this time, it will fire one single query, or it will fire the same four queries. Shortly, we are going to see. See, yeah, flow has been stopped. Now I'm just moving the cursor to the next line. Okay. So as soon as I move to the next line, here if you see, it has already fired four queries. So here if you see, the first query is for a list of departments, and the second query is to fetch the list of employees for what is a uh, uh, so this is for HR department and the sales department and IT department. Of course, we haven't printed anything. So as soon as we execute the first line, that is this highlighted line, so immediately it has fired four queries. Okay, so okay, so that means even though we specify eager fetching, okay, so whenever we fire this find all method, okay, internally it is firing four queries. Okay, so the only difference is between eager fetching and lazy fetching is in the case of lazy fetching, okay, uh, okay, this call has executed only one query to fetch only list of departments, and this piece of code, whenever we try to print employees details, then only lazy fetching has fired three more queries. But whereas in the case of eager fetching, okay, so this particular line itself has fired what do you say, all four queries instantly, right? So now if you see, I'm just resuming the flow. So after that, anyhow, so this particular line, will not fire any queries. Why? Because already for previous line itself has fired all four queries. Okay, anyhow, I will show you. Yeah. So now if you see, it has printed straight away all the details here itself. See, sales department, HR department, IT department. Whereas in the case of lazy fetching, so it used to print the details for each what do you say between, just below the query two, just below the query three, one more department details or something like that, right? So now hopefully it would be clear. What do you say? Uh, so this particular issue, right? So now uh, yeah, so now I have shown you N+1 problem between the department and employee, which was having one to many association between these two entities. So now, as I said, so this issue will be there even in the many to many association and one to one association also. So now let's examine the same thing even in between employee and projects also. So now employee and projects are having many to many association. So for that, in order to prove that one, okay. So here, if you see. Okay, so um, so yeah, so fetch employees. Okay, I am trying to fetch employees. Okay, so here if you see, so what I am trying to do. Okay, um, now I'm trying to fetch employees list, right? So one obviously, what you say? um, one query will be fired to fetch all list of employees, and seven queries will be fired to fetch each employee's project details, right? So total 1 plus 7, 8 queries will be fired. Okay, yeah, I will show you. So here if you see, I'm just moving the flow to the next line. So here if you see, it has, as I said just now, it has fired one query to fetch all list of employees. Now as soon as I resume the flow, it will fire seven more queries. Why? Because we are having seven employees, right? So each employee's project details I'm printing over here. So obviously here if you see, okay, so list of employees, and after that see number one, okay, so yeah, so here if you see, um, so we are having joint table, right? Employee underscore project. So that is having association with the project, right? So and after that, okay, here if you see second query, okay, and this is third query for third employee, okay, and this is a fourth employee, okay, okay. Here I'm printing the details also, okay. So this is the fifth, okay. So this is the sixth, okay. Yeah, finally seventh, right? For all seven employees, seven queries. So I mean, I have shown you N+1 queries problem, okay, even in the case of many-to-many association also. Now I will be showing the same problem even in the one-to-one association also, right? So now I'm trying to fetch a list of projects this time. Okay, now if you see here, okay, list of projects. Okay, so here if you see, so now just visualize the diagram. Okay, we are having three projects and three respective project managers. So whenever I fetch a list of projects, what happens? It will fire one query to fetch all list of projects, and it will fire three more queries to fetch each project's manager details. Right here, right? So total four queries. So yeah. So here if you see, yes, see, it has fired one single query to fetch all list of projects. As soon as I resume the flow, it will fire three more queries. Okay. So here if you see, uh, yeah, so this is query number one, query number two, okay, and query number three. That's it. Over, right? So so overall, I mean, I have shown you this N+1 problem between a department and employee, which were having one-to-many association, and similarly between employee and project, which were having many-to-many association. And finally, I have also shown you between project and manager, which were having one-to-one association, right? So, so till now we have seen the N+1 problem. Now we will discuss about the fix, right? So here, I'm just pulling down. Okay. So here if you see, as I said, I mean there are two solutions basically, join fetch. Here if you see, we are having two solutions, join fetch and entity graph. Okay, so first solution, join fetch. So here if you see, okay, so join fetch, uh, yeah, so this one. Okay, I'm just running in the debug mode. Okay, here if you see what I'm doing, okay, I'm printing the same thing. I mean, same list of departments, the same list of employee details. Okay, so this time instead of invoking a find all, okay, here if you see, I'm just invoking this particular method, find with join fetch. Here if you see, I have written one query. What I have written, okay, so select D from department D. Here if you see, left join fetch. So this is important. Left join fetch with D dot employees. So what does it mean? Okay, so whenever I fire this particular method, or whenever I invoke this particular method, immediately it will fire this particular query, okay, and it will fetch in a single query all the department details and their respective employees details also. Okay, so here left join or inner join, it's our choice. I mean, if you specify left join, I mean, as you know, I mean, it will print all the department details even though if it doesn't have a okay, what do you say, child details also. That's the beauty of left join, right? Inner joins in the sense whatever it has a matching records, that only it will print. Okay, so now if you see, okay, so where are we? So run. Okay, just debug mode. What happened? So okay, so just resuming the floor. Okay, so here if you see, yeah. So this time you see. it has fired a single query. Okay, so I'm just moving this. Yeah, here you can see now clearly. So one single query. Okay, one single query, that's it. Okay, here if you see, it has printed each department and department related employees happily. So here if you see, so this is the employee. Okay, sorry, department details from department left outer join. Why left outer join? Here if you see, I told you right, in the department repository. Okay, we have this one, left outer join, left join fetch, right? So this one, yeah, left join fetch, this one, right? So that's why here you can see left outer join, right? Left outer join, employee and something on department ID, that's it. So by this way, using join fetch, it has fired a single query in a single shot. I mean, it has fetched all the department details and the respective employee details, right? So now our issue has been resolved with this join fetch, right? So now what is one more alternative way? So entity graph. Okay, entity graph is one more alternative way. Okay. So for that, okay, I'm just uncommenting this piece of code. Okay, yeah, I'm uncommenting this piece of code. So here what happens? Okay, uh, here I'm trying to I'm trying to fetch all records information in a single query. Okay, so in other words, okay, here if you see, total 14 queries are being fired whenever I fetch list of departments and trying to print their employee details and project details and their respective manager details. If I try to do, I mean, if I try to print all the entities information internally, so obviously then what happens, it will fire first query number one and query 2 3 4, and each employee's project details also query 5 6 7 8 9 10 11, as I shown you just some time before, and each project's manager details also to pull, it will fire 12 13 14. So right, so I mean, it's firing 14 queries, right? So now in the case of entity graph, what's happening? Okay, so just need to annotate like this at the rate entity graph. I mean, in the repository. Okay, just above this find all method. Okay, so these are the attribute paths. Attribute paths in the sense, in the department, obviously we have employees, right? With at the rate one to many annotation. So and within the employees, what do you say? We have projects, right? So employees dot projects, right? So now even manager details also, employees dot project dot manager, right? So now this, what is this? Type is equal to entity graph dot what is say, entity graph type dot load. So basically we have two types here. One is load and second one is fetch, right? So load in the sense, okay, so whatever I specify here, okay, in my department entity, so these attributes are only acting kind of a eager loading kind of thing. Okay, so all the remaining attributes, okay, will be treated by their what you say, by their default nature of fetching strategy. Okay, so hope you guys understand. I mean, um, default nature of a fetching strategy in the sense, I mean, as I said, one to many, many to many default fetching strategy is lazy, and many to one and one to one are having default fetching strategy as eager. So I mean, as per their annotation, they will I mean, they will consider their respective default fetching strategy. Now the second one is fetch. So fetch in the sense, here if you see, this is fetch. Okay, so here okay, yeah, so this is fetch. So fetch in the sense, whatever attributes I specify here, okay, in the attributes path here, so those attributes will be considered obviously eager fetching, and all the remaining attributes will be considered in kind I mean, treated as a lazy fetching. All the remaining attributes will be considered as a lazy fetching. So that's the what's it, that's the difference between fetch and load. Okay, so as per your requirement, you can decide whether you need a load or fetch, right? Hope you understood the difference between load and fetch, right? So now, so now if you see here, okay, so here I'm just what to say, trying to debug this particular test case. So here if you see, find all entity graph. Okay, meanwhile I will show you. So what I'm doing here. Okay, so one second. Uh, oh, I guess I mean I'm printing all the employees and the departments information. Okay, so here if you see, okay, so fetch with entity graph, resuming the flow. Okay, yeah, go to console and just moving the flow to the next line. Okay, so here if you see, yeah, uh, so now if you see find all in the sense obviously it will come here. Okay, now it will consider the entity graph. Okay, so now in the entity graph, as I said, I mean, what do you say? I just mentioned all the attributes, right? Employee and even project and manager. So now if you see here, okay, so here, okay, um, so but I am printing only department and employees details. Okay, let's see here. Okay, yeah. So I mean, ideally, I'm supposed to print all the information. One second, I will show you. Yeah. So I'm supposed to invoke this particular method. Okay. Yeah, it's fine. But I mean, if we invoke this particular method or the previous method, the overall objective of this particular test case scenario here is okay. So here it will fire one single query. Okay. So here, yeah. So here, if you see, very big query. So department and see here department and here if you see employee employee and employee underscore project and here if you see project and here if you see even manager. So it has established a join left outer join between all the entities single query and after that it has fired of course as I said I mean I just wrongly invoked this particular test case. So here if you see department and the list of employees, now let me correct this. So I am supposed to invoke this particular method fetch all records. So now here if you see, so okay, so now if you see, uh, yeah, so now here if you see, now in this case also obviously it will fire one single query which joins all the entities. And here if you see I am printing all the entities information. So department name and their employees names, their project names and their manager name, everything I'm printing over here. If you see, I just coded with the help of stream operations. Why? Because just my motive is whenever I invoke its child entities, obviously it is supposed to fire what you say uh, respective query, right? So here if you see test case is passed. Okay, here as I said, I mean it has fired one single query. Okay, so this is the single query. That's it. This is single query. So now, okay, I will show you. Okay, um, okay, I'm just commenting this what do you say entity graph stuff. Okay, entity graph stuff. Okay, yeah, I just commented. Okay, so now let's run the same test case once again. Okay, so this time I want to show you. Okay, okay. Now this time it is going to fire 14 queries. So that's what I want to highlight. Okay, I mean how n plus one problem is impacting the performance. So here, if you see in the case of this particular scenario, it will fire total 14 queries. Okay, so here if you see, yeah. So here if you see one, okay, two, okay, this is three, okay, query number three, query number four, okay, and query number five, okay, query number five, okay, and query number six, query number seven, okay, query number eight, okay, and query number nine, okay, and query number 10, okay, okay, and this is query number 11, okay, and query number 12, okay, and query number 13, okay, and finally query number 14, okay, yeah, done. So now, okay, I have shown you, I mean, how n plus one problem is impacting between all these entities. Okay, so finally it has fired 14 queries to print department details and their respective employee details and their respective project details and their respective manager details, right? So now with the help of entity graph, okay, it has fired one single query instead of 14 queries to print the same entities information, right? So just I mean 2 minutes back I have already shown you, okay, how it has fired single query, right? So that is entity graph. Okay, so that is entity graph. Uh, Now we can achieve the same thing even using the named entity graph only. Named entity graph also. So the only difference here is named entity graph. You can give annotation on top of parent entity. Okay, we can just refer that named entity graph name from the respective repository. So now if you see here, okay, I'm just okay. Um, so I'm just commenting this particular one. Okay, so here if you see I'm just commenting this particular piece. Okay, so now I'm just uncommenting here. Okay, so here I'm just uncommenting. Oh, sorry. Yeah, yeah. So here if you see the same find all method, no, now this time same entity graph. Now instead of having attribute path, here if you see value is equal to something department dot some constant is there, right? So what is this constant here if you see? So this is some constant name department dot employee dot projects. Here if you see, so this is the named entity graph. Here if you see name is equal to some name you can give some any name. Okay, so here if you see attribute nodes, right? So now, I mean, in my previous case, straight away I have given the attribute paths like this. I mean, employee and employee projects and employee dot project dot manager, something like that. But now here, if you see, like how I have given attribute nodes is equal to something employee. Okay, value is equal to employees. I am interested in employees. Now subgraph I have given some name. This project hyphen subgraph. So this is the name. Now here if you see, we can specify n number of subgraphs in within this subgraphs. Okay, so this is I mean projects hyphen subgraph, which is referring from here. Okay, so here what I am interested is here I am interested in projects, right? So that means, I mean, um, it will fire single query to fetch what you say to fetch departments and employees and projects information. Why? Because I just specified only these items only, right? Employees and obviously projects. That's it. So right. So obviously department and employee project. So now I didn't specify manager, right? I didn't specify manager. So that means what happens internally? It will fire a single query to fetch all the information about the department and employee and project. Okay, since I have not specified manager over here, okay, so it will fire three queries to fetch three manager details, right? So I will invoke the same here. Okay, so here if you see, uh, yeah, I'm just running the same test case once again, the same fetch all records, okay, in which I'm printing all the entities information. So this time here, find all is having named entity graph step. Okay. In previous case, we are having straight away entity graph with attribute paths. Okay. So just observe here. Now this time we are pointing to named entity graph, but in the named entity graph, we are interested only what you say employees and projects only. So note down this point, only employees and projects. We are not interested in their managers details. So obviously it will fire single query to fetch department and employee and projects. Here I will show you. See single query. Okay. So here if you see what is say employee and obviously employee underscore projects join table and project. That's it, right? That's what I have specified, right, in the named entity graph. I didn't specify manager, right? So obviously for I mean to fetch all the three managers, obviously it will find three queries. So query 1, query 2 and query 3, right? So if I specify manager also within the same, I mean subgraphs, one more node kind of thing, then it will fire single query even to fetch what you say managers details also, right? So hopefully, I mean N+1 problem might be clear to you guys. So I have demonstrated what is this problem and what are the possible fixes to arrest this particular problem. Obviously, in real-time production, I mean, it will impact like anything. I mean, so many queries it will fire, right? So this is the high-level demonstration. So let's wrap up this particular demo. Okay, so here if you see, okay, so what we learned here. So now here if you go through my key points, okay, so in the case of parent and child entities, so which are having association like one to one, one to many, and many to many with each other. So something like this, parent to child. So there are two cases, lazy fetching and eager fetching. So as I demonstrated, so so whenever we try to fetch a list of parent records, only one query is fired, okay, to fetch list of parent records, and n queries will be fired to fetch each parent's child record. So n is the number of parent records. So now in the case of eager fetching between parent and child, so if you perform the same test scenario once again, so this time what happens, okay, whenever you fetch a list of parent records, instantly all child records are also fetched in the same call, okay, with what is say, which fires n+1 queries, right? This is also I have shown you, okay. So now here first query is fired to fetch list of parent records, and after that the n queries are fired to fetch each parent's child records. N is the number of parent records, right? So now after that what we learned, I mean, so what is the possible fix? So first possible fix is join fetch. So I mean we need to add a JPQL query like this, something select D from department D, left join fetch or inner join fetch, it's your choice, okay. So something like this, d dot employee. So obviously in this case also it will fire a single query to fetch departments and its employees details. So second possible fix is entity graph. So I mean, whatever your parent repository, so in our case department repository is a parent repository, so there we need to add something like this. Just on top of find all method we need to add at the rate entity graph, and after that attribute path. So here I mean in the department entity we have one to many association with employees, and even I am interested to pull their respective projects. So obviously I specified employee dot projects. Even I am interested to pull even projects manager details also, so obviously we need to specify like this. Okay, now after that I also discussed, I mean we are having two types. So that is entity graph type dot what you say, load and fetch, right? So load in the sense, I mean whatever we specify here in this attribute paths, I mean it will fetch all these what you say, nodes in a eager way, and remaining all attributes nodes acts as a their default fetching strategy, right? So now if you have one more entity graph type, that is fetch. So fetch in the sense, obviously these highlighted one, I mean acts as a eager way, and all the remaining attributes acts as a lazy way. Okay, so that's the difference between load and fetch. Okay, so now after that we have also shown you, right, named entity graph. So I mean wherever you have your parent entity, just on top of your parent entity, we need to have something like this named entity graph. So okay, so here I mean we need to have I mean attribute nodes, okay, instead of attribute paths. So we need to specify like this. Okay, so something like this employee, and after that subgraph name, and this subgraph's name will be specified over here. And here I mean I just specified, I mean I am interested even projects also, projects of employee or something like that, right? So now we need to refer that particular named entity graph name from the parent repository, something like this. I mean here if you see same entity graph, now this time value equal to the same name, whatever named entity graph name you have given. Okay, here this name, the same name we need to refer from the parent repository. Yeah, so these are the three possible fixes: join fetch and entity graph, and obviously the last one named entity graph, right? So yeah, this is the high level demonstration. So about n+1 problem and the possible fixes of n+1 problem. Yeah. So hope you guys understood about n+1 problem, right? So if you really like my video, okay, just like my channel and share this video and subscribe to my channel.